Introduction, my name is Dave Cramer. I've been involved with the project, Postgres project, since about 1999 as the maintainer of the JDBC driver. I haven't actually written the JDBC driver, I just kind of guide it along. I'm currently working for Pivotal on the Greenplum database project. We've open sourced that. I'm not sure if you know what it is, but it's a massively parallel processing database based on Postgres. It's currently at about, we've open sourced it last September, starting adding features to it up to backpatching up to about 8.3 right now with some backpatches up to, such as JSON-B. Last year I was in New York and I heard a conversation about how bad the driver was, the JDBC driver, with respect to how it was built. Allegedly, this person thought it was very CPU intensive because of the inheritance that, just because of the way the source code was laid out. So things have changed a lot since then, so I thought I'd do a talk and run some performance numbers and just show how much we had actually improved it. So I did just that. So we're going to go through all these improvements and how much faster it is. And so to start with, we're going to do a little history of the driver, what the source code looked like before we changed it, some typical usage patterns, good things, bad things, how to properly use prepared statements, some of the features in Postgres that we leverage with prepared statements and how they work and why they work, and some little nuances. We did some work on batch processing. JDBC has this notion of being able to set or process batches. And then what happens if you set the fetch size. So here's a little history of the driver and various JDBC things. So back in 1997, it was originally written by a guy named Peter Mount. He left around 1999, hence here I am. I was answering questions on the mailing list, and somebody said, hey, maybe you'd like to take this over. So I said yes. I'm not sure that was a good thing, but here we are. So you can see there's about 8 iterations of the Java spec and the JDBC spec. And the interesting thing about this is, I don't know if you know how JDBC is done, but it's actually just an interface. There's no concrete classes in the JDBC spec, and the driver implementer is expected to write concrete implementations of everything. So each one of these subsequent iterations added incremental additions to each method or each class. And so that required additional concrete implementations every time they issued a new spec. So you'd have one implementation for JDBC 3, one for 4, one for 5, etc. So originally when we inherited the driver, it was written using something called Ant. That was kind of the de facto way of building Java programs back then. But the interesting thing was as you can see, we sort of had JDBC, it was the root, JDBC 2, and then JDBC 3. And so what happened was each subsequent one inherited code from the previous interface. So each one of these each version of JDBC had a abstract implementation and a concrete implementation. And we used filters inside of Ant to filter out which concrete implementation we actually wanted to present to the user based on which Java version we were building. The reason we did that was we had to provide a JDBC driver for version 3, version 4, version 5, and we didn't want to rewrite all the code. So it was just one piece of code, and we used filters. At the end of the day, though, the lion's share of the code is all in the bottom package, in the JDBC 2 package. So ultimately, that ended up that there was a concrete JDBC 4 implementation, extended 4.2, extended 4, extended 3G, so on and so forth. And it ends up looking like this. I don't know whether you can see this. Hopefully you can. But you can see that we have one connection object, and it's inheriting from 1, 2, 3, 4, 5, 6 other objects. And that was the basis of this CPU-intensive comment. was that this caused the JDBC driver to be CPU intensive. So, some comments about why didn't you just, there is a way to build the driver without doing this, and you can just sort of say, use -- target in the Java compiler and compile previous versions with the latest compiler. As it turns out, this would have worked. We just didn't think of it. It would have worked all the way up to Java 8. And then Java 8 decided that they were going to introduce a new class that the driver had to import. So in Java 8, they added java.time.asterisk. And if you had an import statement in the class and you tried to load it with a Java 7 runtime, you'd get a class not found exception. So ultimately, it was, we could have gotten away with that, but we didn't. So somebody said, well, why don't we use Maven? And I was my big question was why? And I was pretty hesitant to actually rewrite it because my overarching concern with the driver was to try to keep it, to not break it. And rewriting it for Maven and getting rid of all the class inheritance would have essentially been a complete rewrite. But I was kind of convinced because these reasons. It's somewhat easier to include in your project. You can just say this is a dependency, throw that in, and away you go. However, we still have the same problems. We had to filter out which files are compiled for each build. Ant had filters to filter out which files are compiled for each build. Maven uses a pre-processing. We have a little bit of code in there. There's the actual example, and that will get that will trigger the filter. So around, actually pretty close to now, about a year ago, we reorganized and released 1207, and all of the abstract class machinations have been removed. There's one class file that works for all JDBC, and it reduces the CPU load. The real advantage, of course, is the code is much simpler, and that was the big argument, that we weren't getting any pull requests, nobody was getting involved in the project. So I kind of capitulated, let somebody else do all the work, of course, because I'm just maintaining it, I'm not writing it. But at the end of the day, it is much easier to debug, and it can be loaded into an IDE just by importing the JDBC Maven POM file. It has resulted in a lot more pull requests, and the code is much cleaner. We basically have one class, and it extends one other one, and that's about it. And there's no more duplicate code. The other with Ant, we had lots of duplicate code with all the concrete implementations. So I thought, well, we've got 2 different versions of the driver because we can pull it out of GitHub with whichever version we want. I borrowed some code from a friend, Alvaro, who works at 8K Data, and I don't know if you've ever heard of ToroDB. I thought I'd plug his database. ToroDB is a open source NoSQL database backed by Postgres that speaks to the Mongo protocol. And there's the link to his GitHub repo. So anyways, there's the table and the data. We just create a table. It has one integer, or actually it's one integer, 2 text files. And it's about 10 million rows. And then I have a number of tests that he wrote a number of tests. What do the tests do? First test just selects I from a number, so we're selecting 10 million rows. The next one selects a string from the table. Next one selects an integer and a string. Next one selects a JSON string and actually parses the JSON string. Next one selects it and just uses the column number instead of the column name. There's a little bit of difference in that because there's a bit of a performance overhead by using the name of the column. You have to look up the number of the column using the name. And then the last one does it with a transaction. So I ran the test suite for a number of different JDBC versions, 1200, 1202, 1204, 1208, 1210. 1210 is the latest one. So it was just released last week. And here's an example of what the tests do. We actually use a Java microbench to test it. You can see that this is the one that reads the JSON string. We have a benchmark annotation. And then it processes the query and actually parses the JSON using the JSON parser. There's the main class. The only important part about this is, this actually runs the test, but it does a couple other things. It defines the arguments for the JVM. You can change whatever arguments in the JVM you want. It determines the iterations, how many times you're going to run it. You can have warm-up iterations to warm up the JVM. In this case, the iterations were 20, so we basically read 10 million rows 20 times for each benchmark. So here's the results. It actually didn't change at all. There was actually no CPU overhead, at least caused by having the code be more complicated. So that was an interesting conclusion. Essentially, it just works out that we don't spend that much time in the driver. There's more time spent reading and writing the data back and forth. So turns out that wasn't a good reason to change over to Maven. So the good thing that came out of Maven, though, is the code is a lot easier to understand. Maven is also now sort of the de facto Java packaging system. So we play nice with the ecosystem. There are more people working on it. It's considerably easier to get into an IDE. You just have to import the POM. And it's much easier to push into the Maven repository. I remember having to push from Ant. It took quite a few steps. With Maven, it's just a matter of Maven and tell it to push through the repository. So some things we actually did that really did improve performance. We fixed set fetch size. There was actually a bug there's a deadlock issue that we fixed. We changed the code how batch inserts work so that we rewrite the batch insert. And there were some bugs that were causing some problems. So to test set fetch size performance, I used exactly the same code that we had before in the previous tests. And you can see in this next slide that when you have very small fetch sizes, it's much slower. We get down to the knee is around 100. So set fetch size should be set to 100. Obviously, it gets better, somewhat better at 1,000. During all this, we sort of found there's an insert batch deadlock that we ran into. So the ideal way with Postgres to insert a number of rows as fast as possible is to create a server-prepared statement and then just bind and execute over that n times, and then at the end of it, deallocate it. With lots of rows, we run into a problem. That the driver is busy sending data, so it hasn't pulled any data out, it hasn't received any responses from the server. The server is busy sending responses, so it can't fetch any more queries. So what we did, we ended up having to put in something that looked at the size of the buffers, the actual send buffers, and every once in a while, after so many bind and execs, we have to issue a sync and flush it out to TCP and wait for a response. However, the more syncs, the slower it performs. But so then we get into an interesting subject of how to insert lots of data. A lot of people, the standard answer is just use copy, but a lot of websites don't actually do that. So, sorry. So the simplest way is just for each row, insert, execute. Then in JDBC, you have the option of using insert batch. And then something that people that have been writing a lot of SQL for Postgres know about is you can insert values and you can just concatenate the values at the end of it. So you have row 1, row 2, row 3, up to row n, and then finally copy. So a little bit, just before we get into the actual tests, this is the environment we're in. I was using Java 1.8 on this particular MacBook Pro, and Postgres 9.6, and using the micro benchmark harness that I mentioned before. And the table just looks like this. It's an integer, varchar, and another integer. So this is what the code looks like. You can sort of, it's a little complicated because we use the same code for various things. So there's some, in the benchmark, you can have variables, and you can run the benchmark over different variables. One of them is the number of rows, and the other one is this P2 multi. And P2 multi essentially works out to being the size of the batch. So if we wanted to do a batch size of 128, we would set P2 multi to 128. And it's a little convoluted in there, but essentially what this does is do the rewrite for you. So if you have P2 multi set to something other than 1, we'll end up rewriting the insert so that it ends up having multiple. Let's go back. Went past that. It ends up rewriting it into the third form there, in the third row of data there. So if you have 10 rows and P2 multi is 2, the outer loop is executed 5 times, and we insert 2 rows at a time. So it ends up rewriting it into exactly what that looks like. Insert foo, and they end up values with 2 sets of values for each row. So if we just do P2 multi, it just ends up being the number of rows that we're inserting. For each row, we insert into the table one set of values for each row, and after n rows, we call execute batch. So at that point, nothing until execute batch has been called. We don't execute anything. We don't insert anything into the database. For when we set P2 multi, which is actually obviously spelled wrong, it's greater than 1. We start using the insert form where we're inserting multiple rows per statement. So there's more data inserted per statement, and there's less statements. It means there's less trips back and forth to the database. So so if n is the number of rows, after n divided by P2 multi, we actually run the execute batch. So we're reducing the number of statements and putting more data in per statement. So what the actual performance benefit here, or the performance enhancement, is that we added the ability to specify insert rewrite in your connection string, and then the driver will actually do all this for you. So it'll rewrite the query for you. So for each row you insert exactly normally would insert execute. After n rows, you call execute batch. And then, again, we set the insert rewrite equal true for the connection. So under the covers, JDBC will rewrite the query for you as of 1209. So you have to use a fairly recent driver. The other option that people tend to use in the Postgres world, because they don't have drivers to do all this nice work for them, is to use the copy command. And the code that we have, or the code in the test, essentially just does this. It does copy batch, copy from standard in. It'll create a string in memory for the number of batches per row, and it loops over the rows, creating the input string in memory. Obviously, if you get a lot of data, you're going to create a great big string. We also did a test to see what, this was just an insert struct, where for n rows, set the string to, essentially it looks like that. Multiple inserts in the same row, execute batch. So the results end up looking like this. So once you get up to a certain number of rows, you can see that a plain insert is really, really, really slow. It's about 50 times slower than either copy or inserting batch. So the takeaway here is that you want to have lots of rows in your batch size, and you want to use insert batch, not insert. This is a batch size of 128. So compared to batch inserts, plain ints are very slow. We went through that. Sure, sorry. You know what? I had that in my notes, and I forgot to mention it. No, I didn't. I should have actually tried like a million and see just how badly it blew up. Because I suspect there is another problem at the end of that, where if you put in lots and lots and lots of rows, you're going to run into problems, because you'll be sending that one query to the back end with, lots of rows. Yeah. So you're reading you said a blob data?
A blob data from DB2.
Okay, and a blob data is binary data, or is it?
It is binary data, yeah. But then I'm converting that into hex and then putting it into byte data field in Postgres.
So why are you converting it to hex? Just out of curiosity, I don't know.
I didn't want any, it's in the ZOS machine, so I don't know how the binaries would come out.
Okay.
I haven't done any benchmarks on converting it directly, because I wasn't sure how the copy command would behave if there were like new lines and stuff like that inside the binary. So maybe I should not convert that.
The copy command will not like that. The new lines will create a problem in copy. But you can use, so what version of the driver are you using now?
I think JDBC driver?
Yes.
On the DB2 side, we are using like
And then, are you using a JDBC driver on,
On the poster side,
yeah,
we are using just plain copy command.
oh, okay.
So I was wondering if the insert that would help us, having everything within the Java program.
So the question is, he's wondering if having the using the JDBC driver and insert batch and keeping everything in Java would help. I would have to believe it would. I mean, at this point, there's certainly some overhead in reading it into the driver, writing it out, and then pumping it back into another program to copy it in, unless you're copying it right into the back end.
I'm right into the back end, yeah. I'm just spitting it out to the screen and then doing a copy from STDN into the table.
Well, I think this slide suggests that we're no faster for lots of rows. I mean, copy is pretty efficient. It's just not a particularly Java paradigm, right? So yeah, copy is very efficient. I mean, PG dump uses it. You might have to be a little careful with the characters you have in there. Make sure you are. So you're spitting it out into hex, though, right?
Yeah, I'm spitting it out in text, so that guy I have no problem.
But then how you convert? What do you? Yeah, but you don't end up with a blob on the input side.
On the input side, it's just a binary blob. Like Java reads the binary blob, and then Java has the 2hex function that it can use to convert that blob into a hex. And then once it's in hex, I can import it to any.
Yeah, but you've now put it into hex into your database, though, right?
No, when I'm putting it into the database, I'm converting that to byte array, and then putting it into the byte array. So on Postgres, I think you can do you can just type, there is a function in Postgres that converts that to a byte array.
Yes. Yes. But okay, in that case, yes, you would be better off just reading it as a blob and writing it as a blob. Because you're not going to go through the function. Why would you want to translate it into hex and then translate it back? So with different batch sizes, we can see that for smaller number of batch sizes, copy certainly doesn't work very well. Insert batch works about the same as insert rewrite, because insert batch is actually rewriting the code. But at the end of the day, insert rewrite is the fastest Java standard way of putting stuff in there. So I mentioned we had some bug fixes. This was kind of embarrassing because turns out that we were sharing a value that we use as a flag for the query executor, and we disabled batch inserts, which apparently work really, really well. So when we fixed that bug, we got a 10-time increase in throughput. It's always good to have somebody look at the code, and I guess Mavenizing the code helped out quite a bit in this case. Some sort of not too particularly good uses of JDBC, which are unfortunately very typical, largely because people use ORMs, and ORMs aren't very, they do things, they make things easy, but they don't do things well. So typically what people do is they open a connection, they prepare a statement, select something from foo where ID equals question mark, they execute the query, they close it, they close the connection. This doesn't do, without a connection pool, it's a very heavyweight operation. Postgres uses processes, so each connection is a process. You open a new connection, you open a new process. Most people use pools, so that's not really an issue, but we really don't take advantage of any caching this way. Better solution for using JDBC, open a connection, prepare the statement using select asterisk from foo where ID equals question mark. By default, after 5 executions, we will create a name statement where we do this a name statement in the back end, does something like parse name statement as select asterisk and foo. Then subsequent uses of the execute query will just do bind exec. They won't have to parse anything. They won't parse anything on the client. They won't parse it in the back end. It'll just be binding the values and executing. And ultimately, if you can get away with it, in your case, never close the statement if possible until you're done. Right? Just keep reusing it, reusing it, reusing it. We, in 9.4, in 1203, we put in a client-side query cache. As long as you use, don't use generated queries, such as the one below, where it creates a new string each time, it will, the query cache will be used, and the query cache is an advantage because we don't have to parse the client-side query. So then we also use server-side prepared statements. The one little caveat with server-side prepared statements, don't change the type of the parameter. So in Java, you could do something like, the first iteration, you prepare statement, or you set the integer to 1, and then the next time you set it to a types.varchar, essentially changing the type of the parameter. We have no choice at that point to deallocate and re-prepare the statement. Less obvious issues. As I said, there's a connection parameter called prepare threshold. It defaults to 5 executions. So after 5 executions, or the first 5 executions are using an unnamed server-side prepared statement. And after 5 executions, we change to a name statement. The advantage of name statements, we can use binary mode once we have a name statement, because then we know the types of the tuple, the types of each column in the tuple coming back. Binary mode is faster for a number of things, such as timestamps. Timestamps are particularly hard to parse. They take quite a bit of time. So if you have a lot of timestamps in your data, it would behoove you to use name statements. As we talked to earlier, set fetch size. If you don't set the fetch size, we have no choice but to read it. Oh, sorry.
Can you back one slide real quick? Did this behavior change at any point in the past? Or has it always been 5 executions that began spinning up server prepared queries?
The question is, did this change any time in the past, and did we always do this? I'm pretty sure it has, but I just don't know when. This has been around for quite a while. Why do you ask? Because there's another.
I remember running into this problem and having to disable server prepared queries generally, and then have developers explicitly enable it when they knew they were going to be in a loop. And I was just wondering, because this is a nice trade-off. I like this.
So, Peter, can you help me out when Tom put in the ability to deal with server-prepared statements?
It was in like 9.2.
9.2. So there was an issue that using server-prepared statements were actually slower, because the generic query that it created really didn't help you. It generally was not faster. So then around 9.2, we made it. There was an enhancement made in the actual server that it prepared a number of different plans, and depending on what you passed in, it would choose the right plan. It can still. Somebody else did a talk about this, and there's a way that you can actually, after 6 queries, after 6 server-prepared statements, the plan actually gets really, really bad. And that's been discussed on Hackers, and I unfortunately don't have the slide. But it is something to be aware of. If all of a sudden your query after the 6th time goes wonky, it's not my problem. It's just talk to the hackers. So back to this. We went past this, right? So performance numbers without fetch size, it's about 10%, or this is about 25% better with fetch size. The one thing about fetch size is you have to use a transaction, because we use a cursor. So if you set fetch size with auto commit on, it won't matter. So if you want to, if you're reading a large amount of data, use set fetch size inside a transaction. Yeah, so again, it's the only way to read a lot of data without an out-of-memory exception. Every year or so, I get this. I read my 10 million row data set into memory, and I got an out-of-memory exception. Yes, well, that's what happens. So a bit of a review. We cache parse statements across prepared statement calls in the client, so that speeds up considerably. Execute batch is changed not to execute statement by statement. And a bug in the code disabled batching. The real big win here is rewrite batched insert. Rewrite batched inserts rewrites your inserts from multiple inserts into one row. There's another one that we found in the code that we were cloning the calendar for each timestamp. We get a pull request 376 fixed that. We get a 4 times speed increase for that. As I said, we went over that again. So credit where credit's due. As I said, I'm more of a maintainer. I didn't actually do most of the work. So much of the optimization work was done by a young guy in Russia named Vladimir Sitnikov. Much, if not all, of the work to convert the build to Maven was done by a guy in London named Stephen Nelson. And rewriting batch statements was thanks to Jeremy Whiting. Any questions? We got a few. Any more? Sure.
Do you use the binary format for certain data types, and if you do, have you run into any problems with that?
Question was, do we use the binary data type or binary transfer for certain data types? I kind of thought I went over that, but yes, we do. So as soon as we go to a name statement, we switch to binary, because then we know the types that are coming back to us. We have a problem with some of the timestamp issues. It's very, very hard to tell. But for strings, integers, numbers, yes, we use binary where we can.
You had problems with timestamps?
Yeah. There's issues with what to do with. So Postgres has timestamps with and without time zones. Java does not. So when you get a timestamp without a time zone, what do you do with it? We've had lots of people, well, I think we put it into the local time zone, but we have people say, well, we don't want it in the local time zone. We want it in the server time zone. I don't know what the server time zone is. So there's plenty of arguments on the JDBC list about that particular question. So I don't have a solution for it. Somebody should just get rid of one of the timestamps. Or put one of the other ones in Java. Anybody else? In that case, thank you.
PG Bouncer.
Yes.
Recommendations for PG Bouncer for performance, if any. Disabling, again, prepared statements is kind of the only thing that you can do right now that I'm aware of. Is there anything that you're potentially aware of?
We don't usually see too many people using PG Bouncer in front of Java just because Java tends to have its own pooling mechanism. But no, I can't think of anything. There were a couple of bugs that we ran into because I think we try to change some things. We issue a few startup commands in the packet and fixed loading point. We set it to we set the encoding. There's some other stuff that we do that didn't play well with PG Bouncer. But I think we fixed all of that. So.
Why would you use PG Bouncer?
I've got 200, 300 web servers all running JDBC. I still get a huge benefit from a connection pooler in front of Postgres.
Yeah, you do.
But why not a connection pooler on the JD? Like, why not run?
On each box,
Yeah.
because I've got 200 or 300 of them.
Because he doesn't want a connection pool on every box. He wants to have one connection pool.
Yeah.
Or he wants to chain connection pools, and he also wants to be able to use the ability to switch it out underneath it so it doesn't know that it's there.
For maintenance too.
Yeah.
Where you can pause writes to a master, do a failover.
Yeah.
Have the connections maintained or be maintained by the clients, change out the back end.
That's kind of the cool thing about PG Bouncer. It lets you do that.
The indirection thing.
You're smiling. You don't use PG Bouncer like that.
There's lots of non-cool things about it as well, so.
Yeah.
Yeah. Well,
Yeah. So that's why I was asking, because
Okay.
here's gonna cause their own issues.
yep.
It's close.
Okay, thanks.